All right, so our first example says that two flasks at the same temperature are joined by a glass tube with a stopcock. Be mature, Sarah.
Oh, okay.
You don't want to stop the whole lesson.
Yeah, you don't want to
make sure nobody's laughing. I don't think nobody will.
You don't remember Sarah when we did the redox?
Yeah, she didn't even know what
I thought it was stop cook. Okay, I read stop cook.
Flask A is a 4.0 liter flask.
You gotta be over here nervous.
At 2.0 atmospheres, while flask B is a 10.0 liter flask containing carbon monoxide at 1.4. What's the final pressure in the flask after the stopcock is open? So there are two things to do to this. You have a Boyle's law equation to do on this, and also a Dalton's law. Okay. Because is the volume, will the pressure change when the volume changes? Yes, okay, we know that. We know if we increase pressure, if we increase volume, we're going to decrease pressure. We've got to do a couple problems to this first, okay? Got to do a couple problems to this first. So I'm going to break this down into two sides, okay? The into side.
So that's just like, what is that white thing? Is that just like an extra marker?
Yeah, it's a glue stick. Into and CO, okay? I'll break it down into two sides. And I'm going to do the P1. There's no temperature, so that's I'm going to do a Boyle's law. P1, V1, P2, V2. And over here, I'm going to do a P1, V1, P2, V2. What is the initial pressure of N2? 2.0 ATM. Okay. Once again, when we're dealing with Boyle's law, the pressure does not matter what unit it's in as long as it is in the same pressure. Okay, what is the volume of the N2 initially? 4.0. 4.0 liters. Once again, same thing, as long as we're in the same units. Liters, milliliters, doesn't matter as long as we're in the same units. Now, centimeters cubed is also a volume. P2, what's that? No. P2.
Oh, P2 would be 4, 4
Nope.
plus 10 be 14.
Nope.
No, that'd be volume 2, but P2 would be.
P2 is what you're looking for. And what is V2? Justin, what is V2? 14. Because I have that once I open the stopcock, my volume becomes the same. Over here, I need to do my CO also, don't I? My initial pressure CO is 1.4, correct?
Yes.
And the volume is 10.0. I'm looking for P2. That's my question mark. Notice my V2 does not change on each one of them, okay? My V2 does not change on each one of them.
How did you know to add them?
Because if they're separate, when we open it up, they all become one.
Oh.
So, if they're not, on your homework, you actually have 3 flasks that are added together, so you would have 3 Boyle's law problems. And, the volume would be add V1 in each thing. So, it'd be 2 times 4 equals X times 14. And over here, it'd be 1.4 times 10 equals X times 14. Well, this one's 1. Divided by 14 is 4 out of 7, so that's 0.5. Hold on, 1.43 times 4, 0.586. Anybody doing that?
1.75.
What?
14 divided by 8.
8 divided by 14. 8 divided by 14. 8 divided by 14.
Is 0.571.
0.571?
Yeah.
What did I say? 0.576. 0.5. I only need 2 steps to figure 0.57 ATM. I haven't answered my question yet, though, have I? I have yet to answer
final pressure.
The final pressure. So what would I do? Add them. So the final pressure, so P total would equal the 2 numbers added together.
used to set these up different after like,
Same way.
I remember doing it.
P total
That's
equals
still different.
0.57 plus 1.0. What's the answer? Wrong. 1.6. I'm adding and subtracting, so I only care about numbers after the decimal. Or 1.618. That's Dalton's law of partial pressures. Okay, now that one was probably one of the more difficult ones that we had to do with this. The last example I want to work is talking about water vapor. And we've already done this year also.
I mean, I don't care, but I'm just saying it's like more convenient for the gonna start flowing in.
It's going to tell you, man, I can't copy and paste that. A 25.0 milliliter sample, a 250 milliliter sample of oxygen. Sorry, I can't copy and paste this one. Actually, I'll type it and then go from there. Second question tells you a 250 milliliter sample of oxygen collected over water at 25 degrees Celsius and 760.0 torr. What is the pressure of the dry gas? The vapor pressure of water at 25 degrees Celsius is 23.8.
Is this the one where we have to consult the chart every time?
Yes, but I gave you the information on this one already. You don't actually have to go look at the chart. Hey, Seth. Nice over note.
Yes. They're singing like
So,
so much.
how would I set this one up? Justin is correct. I have to go consult the chart. Typically, I don't have to consult the chart on this one because I've already given it to you, okay? I've already given it to you. So how would I set this one up?
We started doing this at the beginning of the year. I remember.
I think I still have like the worksheet.
Is this a Dalton problem? What?
It's got
Well, there's
pressure,
pressure,
temperature,
and volume.
and maybe got volume. Yeah, it's all pretty
The
good.
millisecond, is that volume?
That's P1, B1, P1. No.
This is still Dalton's law problem. Okay. This is still Dalton's law problem. Anytime you hear anything about dry gas is the code word for Dalton's law. So P total equals P vapor plus P gas. Do I know the total pressure? 760 torr.
Why is 23.8?
Because, as Justin had said a while ago, this is the one you have to go, when talking about water vapor, you go consult the chart, okay? And so if I wouldn't have given that to you, you would have to go look up what's the water vapor, what is the pressure of water vapor at 25 degrees Celsius.
Will we get the chart on the test?
It'd probably just be something like that. It'd probably just be something like that. Because I'll probably give it to you in the thing. So I know my P vapor is 23.8 plus P gas. What's the answer? 700 and by adding, subtracting, multiplying, dividing. Subtracting.
736.
That's wrong. 736.2. And that's today's lesson. Dalton law of partial pressure. Okay, now one probably the more difficult questions today. Your homework today is a Google Forms. Okay, so Google Forms is a mix of all gases. Okay, all right. There are some ideal gas laws. There are Dalton's law. There are some combined gas law. It's a mix of everything. I will